All right, so looking at this, the second time I'm doing this, because I messed up so badly the first time around, today's date is going to be 5/16. So this one's all about potential energy. You guys should have a pretty good understanding of what potential energy is, but who knows? So the first thing you're going to put is the definition for potential energy. Okay, so that's what we're going to be focusing on first, is what is potential energy. And a lot of you can pretty much just say it's stored energy. However, for a more scientific approach, so in 8th grade or whatever grade you make it to, and you take a physics class or a chemistry class, and you're talking about energy, if something has potential energy, what does that actually mean? It is the, let's see, will it work? The energy stored in an object. So the energy stored in an object. And again, I'm going to cover this up more just because I feel like some students are just skipping right to where the larger portions of content are written and then ignoring everything else. Of an object due to its position, charge, positive or negative, charge, stresses, and other factors. Okay. So due says the energy stored in an object due to its position, charge, stresses, and other factors. That is the definition for potential energy. Okay. Looking at gravitational, so now we're down here, gravitational energy, gravitational potential energy. Briefly went over this one on the other paper from yesterday, but we're going to do it again. So the energy an object has, the energy an object has due to its position above Earth, due to its position above Earth, and the energy due to its height. So like I said in the last video, the higher up an object is, the more gravitational potential energy it is. If it's just 1 inch or 1 centimeter above the ground, it's not going to have gravitational potential energy. However, it's really not going to have that much gravitational potential energy as opposed to something like, let's say, in an airplane. Okay. So looking at this one, we have magnetic energy. So what exactly is magnetic energy? We have our little, this is red, right? So I'm just going to color this in because I can. Magnetic energy, just remember on the test would ask you about different forms of magnetic energy, or should be different forms of potential energy. Gosh, I can't color in the lines today. There's different forms. Anything that's moving, so for example, like radiant energy is going to be kinetic energy. If it's moving, any part of it is moving. Mechanical energy is going to be, what's it called? Kinetic energy as well. So magnetic is the, do I always start with the energy? They do. The energy, a magnetic object has due to its position and orientation to other magnetic objects. Hope you remember the two elements that are magnetic, or some of them that are magnetic, are going to be iron and nickel. Did I just forget that? Who knows? Like iron filings are usually used a lot to demonstrate magnetic properties because they're easy. The Earth's core is going to be iron and nickel as well, which is why we have a magnetic field. All right, electrical. We're going to talk a lot more about electrical energy as well, but it is a form of potential energy. So this is the energy, and they all start with the energy. The energy and electrically charged. I don't know if I'm on the energy and electrically charged object has, due to its position near other charged objects. Okay, so due to its position near other charged objects. So like think of like static electricity. If you rub your feet on the carpet, and you might be able to shock somebody else due to that. So it's just like the position near other charged objects. So chemical. Again, we've talked about this one. We're not going to talk about this one as much as, let's say, we're going to talk about nuclear and electrical, but chemical is still important. Anything that has kind of stored energy in it, gasoline, wood is a good example of chemical energy. Food, definitely. So this is the energy an object has, oh no, hopefully it's not dying. The energy an object has due to its chemical bonds. Okay, due to its chemical bonds. It is released during reactions and phase changes. So remember, phase changes, solid to gas, gas to sublimation, liquid to gas, liquid to solid. Yeah, freezing, melting, condensation, evaporation, sublimation. The last one is elastic potential energy. So a lot of times you're going to be thinking of like a spring, or you can be thinking of a rubber band, each one. So it could be if it's compressed or if it is stretched. Whoops, that's not a twisty pen, Miss Penny. So let's see. What's the last color I would like to use? I didn't use pink at all. Have I used pink? No, I have not. I used red. Oh, no, it's last go. I used blue. Blue a couple times. Oh, well. All right, the last part is elastic energy. It is the energy an object has due to, the energy an object has due to the stretching or compression. So when you're compressing something, compression of an elastic object. Wow, that's so difficult. Cool.